Thank you very much, Chair. So we have we've about 25 minutes, I think, about 25 minutes for questions. I think Elena is going to rove around with a microphone. So if you have a question, if you'd like to put up your hand and maybe just introduce yourself before you ask your question, the company you're coming from. And just so if anybody has any questions, I'd maybe just like to lead out with a question I have, and I'm not sure who's best placed to answer it, but I think, we've had 4 very different perspectives on energy storage. It seems like there's lots of different opportunities, there's lots of potential, but it's a very fast-moving business. So I guess as a customer, how do I choose what's the right solution and not pick the wrong horse in this race? So maybe James, do you want to?
Well, I'd echo what you said. There's been the presentations have shown that there's a lot of innovation. We've heard in Tesco. A lot of different products have been tried in different stores in Ireland, different facilities in Ireland, and also there's a lot of different ways you can cut a business case together to do that. The key, I think, here is to identify technologies which give flexibility, and then identify partners who can work with you to use that flexibility in the way which the regulation at the time will allow best you to capture value for that flexibility.
Anybody else want to jump in there?
I suppose just even the experience we had with the biomass boilers when we kicked it off first approximately 3 years ago. It took a lot of work to get the first one commissioned right, working well from a Tesco perspective. But by the time we came to the second and third and now the fourth, we got it honed quite well. They are working very well, but just an example about the importance of the storage perspective. You can apply this to the mechanical or the electrical side. On one of the projects, it was Mullingar, we installed a 250 kilowatt boiler. My view was that at the time from our data, and in Tesco, in fairness, in our predecessors, there's very good monitoring in Tesco. So we monitor everything. We've got good data. But saying, look, really, you should be maybe looking at a 350 kilowatt boiler, but also the buffer tank, 5,000 or 10,000 litres of buffer storage. Now, it was an ESCO project, and we didn't, so we're buying the energy, whether it comes from oil or wood chip, we pay the same amount. So it's risk-free to Tesco. So we pay a little bit more, but it took away the risk. But the biomass boiler supplier at the time, of course, he was going to cost him a higher capital cost to put in a larger boiler, but also slightly higher capital cost on the buffer. But I was looking at the last month at the usage in the Longford store, which with the optimum size of boiler buffer, and it's using 40 litres of oil a day in addition to our wood chip, and Mullingar is using 250, 260 litres of oil a day. Now that's fine at the moment while we've low oil prices, but I said to the supplier, to the ESCO provider, I said, Mullingar is going to start costing. He says, we know that and we're looking at it. So they're going to have to retrospectively go back and put in storage, put in buffer storage or the equivalent of battery storage in electrical perspective. So luckily it's cheap to do. A buffer tank is just going to sit there, and it's like a battery, there's no moving parts, etc. But it just really drives home the point that for low capital investment, how important that storage is. So it's and we've seen it on the oil usage.
Just on that particular topic, we obviously have found out there that there's most industrial customers and a lot of commercial customers have storage that's available to them for no capital cost. So if you just take the simple example of a cold store, it is effectively an energy storage device. It can be manipulated in temperature, as you were describing earlier on. it can take in energy at certain times, and then it can be manipulated or interrupted at certain times to basically take load off the grid. It can also be turned on at certain times and driven to those lower set points and actually take energy from the grid. So it's an ideal possibility at no cost for balancing frequency on the grid. We've found that there's very similar assets available in the water industry. Buildings like this have temperature set points on them which can be manipulated. We found, surprisingly, that in the industrial market, there's a huge amount of storage. So if you even take something like a paper mill, which is a reasonably complicated place, there's normally storage between the processes. So they can actually implement schemes that you wouldn't think they could implement. And that's true right across. I think we've identified 11 segments in the industrial market where there is indeed storage existing already, and they're capable of carrying out these schemes. So there's a lot of very low cost and no cost options from a customer perspective for grid balancing available before you ever think about a battery. A battery is a good thing and will be used, and we would look at them on the sites, but our general modus operandi is obviously from a customer perspective to look at the low cost and the no cost things first, then look at the cost of various things. And sometimes a battery can be quite a nice supplement, but it still has a cost. And we just found that across most industrial segments and across the commercial segments certainly, there is no cost solutions to storage today.
Great. So we have a couple of questions. Yeah.
Yeah, hi there, John Fitzgerald from Black & Veatch. Just to pick up on the battery point and to allude to the opening comment you made, James, about affordability. One of the things we're coming across in the UK in terms of the integration of batteries and also looking at the Irish market is to be able to afford to pay that extra for the battery. You know, there's a lot of talk about National Grid and DS3 services for fast response, but there's also a need to stack other benefits in all reality to be able to actually afford the asset. In the kind of environments you're talking about today on behind the meter on a customer's site, what kind of benefits do you see battery bringing in addition to providing those that mainstream revenue through National Grid? So that's kind of a question to anyone on the panel, but James, maybe if you want to start. Thanks.
Thanks, John. In terms of, again, it comes down to the individual, the specific customers' processes. What can a battery provide? It can provide the reactive control, reactive power. So improving the power factor, if that's a specific issue at the site, it can support that. It can support providing. It can support if there's a very peaky load at a customer who's being charged significant maximum input tariff. The costs on the maximum input capacity is a large driver. Then it can avoid those maximum charges. I think we heard that from for a case with Siemens there in Germany, and potentially the various specific things within the processes which we'd be sure as you explore in a given customer. Having a battery could be providing potentially backup also. If a battery can be providing a level of backup or black start to avoiding a diesel generator. I think maybe some of my other colleagues here will have other ideas of uses, and I'm sure as it develops, this stacking of different use cases is exactly what's needed, and it becomes quite particular to the given customer.
We came across one recently, which was for critical power applications where you just could not have an outage. And in data centers, for example, most people have a UPS, but we don't see this so much in industry. And but today, the whole concept of a UPS and the space that's needed and the degradation of the batteries over the time, because they're generally lead acid batteries, so they don't have such good lifestyle characteristics. And then also, if you've critical sites where you have a lot of diesel storage, all of this can be considered now when we start to look at asset management as stranded assets. So one thing we were trying to build a business case for, and it's not finalised yet, was for a critical process whereby we could use the storage for the UPS plus the backup diesel generation plus peak load management all within the same asset. So thanks to the lithium-ion technology, you'd have this really fast to respond asset, or could even sit there online if needed and act as a UPS. But then also if you had like a trend in a daily peak, then you could address this. But then also you've got a longer duration if you need a backup instead of a diesel generator. So customers like BT, I can't remember how many litres of diesel they have stored in all of their sites globally. And this, I forget again the cost, I wasn't working on this calculation myself, but the cost of keeping this diesel there stranded, not doing anything, it has a cost on the balance sheet. So if we can start to look at battery technology or battery solutions that can do all of these different features, then it starts to be quite attractive. I agree, normally if it's just one application, it's almost impossible to make a business case. But if you start to mix them up like this, then it becomes quite interesting.
Okay, we have a question there.
Are any of your guests developing a tidal storage? And if they are, can they comment on it?
So, sorry, what type of storage?
Tidal storage.
Tidal storage.
Yes.
That's a great question. I think
Storing the
James, you
tides,
probably-
In my previous work, I've been doing a lot of work in ocean energy, and mainly in tidal storage. There's an element of dispatchability in some of the tidal range projects, but generally there's not a large storage element to it.
Hi, Kieran Coffey from Maynooth University. I have a question for Gerard. Gerard, have you considered using your existing refrigeration plant on nitrate to produce, say, ice for summer cooling?
Well, not necessarily ice, but that's similar. What we did do was just increase the set point and lower it by 3 degrees in that situation, and then allow it, that takes the load off during the day. So it's a similar concept. Oh, sorry, sorry, I misunderstood you. We do have cold aisle retrieval, which we do use for cooling the store in the summertime, and it also solves the problem of stopping those cold aisles where we have all our cold goods becoming too cold and uncomfortable. So it actually keeps it at maybe 15, 16 degrees. And then the rest of the store, when it's going to, our set point is 19 degrees, but in the summertime we'd start hitting 21 and 2 degrees. So we actually utilize the cold air and put it into the warmer parts of the store to keep it cold. But going the further step and increasing the set points at night time then to give us cooling in the store and during the daytime, no. So what we want to do first of all is prove the concept that the minus 24 works, and the results we're looking good, but we need to kick it off again.
Just on that type of manipulation would be quite common in, say, across a refrigeration plant in distribution centres and that. I think we've something like maybe 80 of those, and we would do that. More manipulation against the tariffs across certainly all our estate in the UK. We would manipulate them against a tariff, which is to avoid peaks, basically. Yeah, we would pick up the low-cost electricity and carry it, because over there there's triad charges in the winter. There's also duous charges every single day, which are quite high. So you're normally trying to manipulate the refrigeration plant, basically, to allow you to get across those peaks as best you can. So that's quite common, yeah.
Great. Okay, thanks. We have a question just at the back.
Hi, Don Hoban here from Crystal Air PCM. We've developed a phase change material primarily aimed at the cooling to shift the load from day rate to night rate. Number of successes with the consultancy houses at the design stage, but the practical experience has been when we've gone to tender, the projects tend to be over budget, and the first thing that gets looked at is energy saving devices that as an expendable. How does the panel ensure that the energy saving devices stay as part of the project?
If I could solve that, I'd be probably the most successful energy manager in Ireland. But it's just, we experience the same, that it's, what you'll often find is that the new build team doesn't have an energy function within it, and it's just, it's capital driven. Now we're trying to change that and get a stake at the table, but yeah, it's a challenge, and it's much higher, even above the energy manager's function. You know, it's at the top table these decisions are made. But I fully agree with you. It's
just at a different level. I suppose our approach is what we do is return on investment based. So if there's a particular technology that has a business case against, I suppose, smart tariffing and smart grid in particular, and it gives a pretty quick return, probably less than 12 months, then we would finance it ourselves.
Hilko Hakman, Electric Ireland. I have a question for Jur. I think it's great, all the trials you do in Tesco, trying new technologies. Have there been any technologies that didn't work for you, that you say after the trial, forget about it? And which trials worked well for you? And last bit of my question is, have you reached a stage now that you say, yes, we've done a trial on a certain technology, this is how we're going to roll it out in other stores, or will you keep on trying new technologies moving forward? What's your policy there in Tesco?
the policy. No, we'd always try. We'd like to keep on trying technologies, because good or bad, we learned from them. And at the end of the day, if it's in one store, it's not going to break the bank to try it out. We get a lot of people coming in with different ideas and concepts, and we always listen to them with an open ear. And if we think there's a possibility, we'll take it on board. Actually, just to pick up on Michael's last point to that question, there are times we've used a similar where if the gap, we try and close the gap between a technology, say if there were T5s being put in a store and the LEDs could be put in and it was a new store, we'd actually fund the difference, because we say, look, we're only going to be looking at this in 2 or 3 years' time again. So we've used a similar way of getting over that in some instances. Yes, there have been lots of cases. We've gone after, say, the cooling in the smaller offices in Tesco stores. We've gone after the split units. We tried that in 5 or 6 stores to see if we could really get a significant return, and we didn't. We tried it in 5 or 6 stores and decided we didn't see it. When we monitored it, we didn't get a good enough reduction. But we tried it in 5 stores. We have 150 stores. If it had worked, great. It didn't work, move on. Something that did work well for us was the over-door heaters. So when you walk into a store, you'll feel an air curtain blowing down on you, and that helps us to stop the heat loss from the store. Also, it has a health benefit that it stops flies, etc., coming into the store where we're selling food. But we took a decision, again, based on monitoring, and that's, I suppose, one key thing, if we can all take away from today, that the importance of good monitoring. We'd monitor our stores to within 10% of unmetered. So when we're 90% metered in a store, we're quite happy. But any store that was using more than 500 kilowatt hours a day on the air curtain, we decided to transfer over to LPHW to run it off of natural gas or off of LPG. So now there's the difference in, say, you're paying anything from 12 to 15 cents a kilowatt hour for electricity, and we brought it back to LPHW. And that worked very well. Initially, we were putting up new over-door heaters, and then we used the Irish companies then and bought the actual coils from the Irish companies and left the skeleton of the over-door heater there. So it's like putting a new engine in a car. And we rolled that out across 15 stores. And we were getting return on investment of anything from 18 months to 2.5 years.
Yeah, Stephen Douglas from the Electricity Association of Ireland. Bridget, you mentioned there's been a big upsurge in the demand to provide balancing services to the system in the UK, and I'm just wondering, what's the balance in terms of that demand between existing sort of participants, providers, and new providers, and what are the different demands that both those classes might have in terms of remuneration? And finally, is there a procurement model, do you think, that can satisfy both parties, so the existing provider and the new provider who might need a bit more in terms of revenue? And if anyone else wants to pop in on that as well, thanks.
I think there's still a long way to go on this balancing service. Certainly the latest one, the enhanced frequency regulation. So I think the other balancing services, like we mentioned earlier, so the fast frequency response and short-term operating reserve and triads, critical peaks in the winter, all of this is quite well established now. But a new product, which is enhanced frequency regulation, which is the new call, this is where we've really seen a massive response from battery storage to this specific call. I think up until now it's been more like demand side response, curtailment of load or other storage services that have already been discussed here. But for this particular call, 70% of the bidders were offering battery storage. I think because it had to be at full power within 1 second, and the hold time was very short, even though it's now been extended. And regarding the price, the market price is not yet set. So I think that the idea was that the market would set the price. So there will be a bidding system, and those contracts that will be awarded, they will be for the lowest price per megawatt hour for 4-year contracts. So I think we will see in the next, I think by June, July, we should see what the market prices are for this as well.
I suppose also responding to that question from ESB's point of view, we'd of course not be a new entrant to any market like this. But it is something which we're very, very aware of, that the electricity industry is changing, particularly in the UK. You've got a lot of companies who've cut their teeth coming in the solar business. And it's something, particularly in ESB innovation as a whole, that's an area in ESB which we're looking to understand that market through our work in our venture capital fund, Novus Modus, to understand these new entrants, how they work and how we can learn the good practices which they bring, particularly speed. And some of the outputs we can see from that are things like downstairs we've got the Kingspan ESB joint venture in terms of rooftop solar. And the various things like this where we're learning from those fast speed, but also bringing the benefits which we have in terms of our heritage and our depth in understanding of the electricity industry.
Yeah, it'll be interesting to see in this call, because it's probably about 50-50 in terms of traditional players and new entrants or newish companies. And I'm talking to both. The more traditional companies have, they're saying we build the assets, they last for a very long time. It'll be very strong, well built, reliable, available. But we expect this level of return on our investment, and et cetera, et cetera. And whereas the new guys, they expect a lower return, they don't expect for the asset to last for 10 years, 15 years. But what will be interesting will be whether, when the contracts are awarded, whether there's actually some weighting for this comfort feeling over the security of how past companies have interacted with the grid and how they will provide the services, compared to the new guys who will be much lower in price, I have no doubt, but they may not give the same level of confidence in terms of how, providing, or the reliability related to grid services.
I suppose we've kind of lived that a little bit in the UK in terms of how the market evolved over there, and I guess it'll be something similar here. I suppose what happened over there is, colleagues were saying there, it is a very fast-moving market. I suppose some of you may be familiar with a thing called DSU here. That came in the UK 5 or 6 years ago, maybe a bit longer. It probably had a 2 or 3 year life, and then it kind of fell off a cliff and went very low in value. Then they brought in various frequency response schemes, and set prices on them, and then those prices have tended to fall, especially as embedded generation, in particular standby generation, has tended to get involved. The reality is in that market, and I don't expect this one to be any different, you need to be very nimble, and you need to be able to find, because I've heard multiple revenue streams been mentioned a good few times, you need to be able to, I suppose, be very innovative, move very, very quickly between the schemes so that you can actually read the market reasonably well. And I suppose the second thing is you can't expect till we get to a kind of a situation of stability, probably in a few years' time, that any scheme will necessarily last any length, because there's probably too many new entrants hanging around at various parts of the market. And when the posse arrives, the price tends to fall and you tend to move on to the next thing. That has been the case to date. For people like us, obviously batteries are a great thing in that they're going to set best new entrant price for the next few years, in particular for frequency response, voltage regulation and things like that. So there's basically going to be a balancing between batteries and existing assets to, if you like, deliver those services. But I think if you're not nimble in the next few years in this particular market, it probably will pass you by. Maybe like this experience you saw in the States before. I think it's going to be a fairly fast-moving market.
A question here.
Sorry, Dan Toomey is my name, water power engineering. The fluctuation of wind generation, how is that controlled? Or it goes from maybe 50 kilowatts up to 500 kilowatts or up to 2 megawatts. How do you manage it?
So ESP has around 250 megawatts of wind generation in Ireland, and another 150 in Britain, around 400 in total. So at the moment, as you say, when it's windy, the wind turbine can generate, and when it's not windy, the wind turbine can't generate. That's fairly self-evident, I think. Ireland at the moment can accept 55% of its generation at any instant from wind energy. In January, over the full month, around 40% of Ireland's electricity was generated by wind. At times, there was enough wind on the system to provide 70% of the given demand on the system at any time. What happens at that time, say it's 3 in, there's not a huge demand, there's more wind on the system, the wind turbines are given a signal by the grid operator, EirGrid, and are turned down. One thing which we're working on, which is more on the grid side storage, is a very large project between ESB and a number of other Irish parties and a number of Japanese companies, is to put down Woodhouse Wind Farm, which is ESB's newest wind farm in Ireland, a 20 megawatt wind farm in County Waterford, to put a large battery, a containerized battery, on that site, so that you could be providing, so that you could be managing one of the services that battery will be doing. As we've heard about, batteries or energy storage will always do multiple things, but one of the things they'll be doing is managing at those times of very high wind generation, controlling the amount of wind generation which would leave that wind farm and go to the grid, so storing some of that excess. What we'd also be doing is providing grid services and potentially some other services. So that's putting a battery at a wind farm is one way to do that. The other way is in those times when there's more wind than the system can hold, is to turn down wind.
Great. Okay, I think we've time for 2 more questions, if that's okay. So I think we've got one at the back.
Damien Costello from Decode Innovation. I'm a specialist in market disruption, and the tipping point in a paradigm shift is when the new good outweighs the old bad. And obviously the biggest challenge in this whole space is the crazy prices of oil are not bad enough to make the good economic at the moment. But what, maybe for Bridget, what is the latest thinking on the trajectory of battery prices? And is there a particular milestone in the not too distant future that we should be looking out for?
I can make business cases work today, lots of them, even with really low oil prices. So it just, again, depends on the application. And I was just working in the headquarters. I only came here 1 week ago, and I spent most of my time crunching numbers, looking at different regulatory environments, different applications, different incentive levels. And generally, if you, like we said, we've said it many times, if you combine revenue streams or you can mix up applications, you can make a business case work all day long. Even today, with low oil prices, I tell you now, I've thrown many calculations in the bin though, thanks to low oil prices. But still, for me, it's not a problem.
It wasn't, sorry, the question wasn't about it being a problem.
Yeah.
If the answer was there wasn't a justification, this activity would stop and we would be having these conversations. Obviously, there is a case that can be made across the board, and there's progress. There's obviously progress being made, great progress being made in light of the oil prices. But in terms of the long-term trajectory on batteries held up the advent of smartphones. Battery technology is one of the biggest blocks here in terms of the entire system, but particularly in terms of storage. Is there any intelligence on that? Any new information on that?
I mean, it's so hard. I don't have I wish I had a crystal ball, but if I tell you, I told you already the prices have crashed. But also, I give you an example of energy density. So racks, one rack, I don't know, 900 millimeter rack, standard rack size, I think, and 600 millimeter rack size. I get double the energy density out of this that I did a year ago. So this is how fast things are changing, you know, and I really can't look into the future, but I think now is the right time, and I think this response to the National Grid EFR in the UK is a clear demonstration that the market's ready. Yeah.
Thank you. Okay. Maybe just one question here. I think we have one question at the back as well.
Yeah, Neil Walker from IBEC. It concerns a question about the diurnal swing in electricity prices and whether or not that is predictable. I mean, we don't even have a day-ahead market at the moment. We will have one in 2 years' time. But you don't yet know, will there be a smaller or larger difference between the peak price and the night valley price? And similarly with the DS3 for the ancillary services, there's going to be a whole rake of auctions, but no one's quite clear what the outcome of those is going to be. So I guess it's a question about uncertainty, and including regulatory uncertainty.
Okay, that's a good question. Maybe Michael, could you take how do we respond in an uncertain environment?
Well, what it tends to do is obviously if an environment is uncertain, but you have visibility for, say, I think in the battery instance or the enhanced frequency response instance, they're given 4-year certainty. So if you have 4-year certainty, then obviously you have to get most of your return in that period of time. Generally, the way the ancillary service market is developed in the UK is you have 1 or 2 year certainty. So that means then generally your return on investment has to be 1 to 2 years. So I suppose what it does force you to be is very efficient. So you tend to find the things, it'll squeeze the efficiency, if you like, out of the system. But what it makes difficult, obviously, is if somebody wants to make long-term kind of capital investments, then it can cause some issues. And I suppose being practical about it, that's probably a bigger issue in the UK than here at the moment, in that our market is a good bit away from peak yet, in terms of having a requirement in that area. The UK is right up there, but they're still kind of living with that type of system, whereby a lot of the things are reasonably short-term. But it certainly served them pretty well so far in terms of it squeezing the efficiency, if you like, out of the system. In the long term, I suppose if they see problems coming over the horizon, then they'll tend to solve them in different ways. There's always monetary ways of solving things, and there's always loads to be found, or different things to be found, if you like, that will get you out of the one time in the 5 years or 1 or 2 years that you're concerned about, that you could have a massive imbalance kind of situation, and how you manage that. But our experience certainly has been that the planning horizons are shorter at the moment, and it means that you're working in an environment of uncertainty. So you have to look at the schemes you have, how long they last, and therefore what your likely return is, and then obviously what's coming down the road. But there is not this. It's not like before. You can't. I'm used to work in the power business, so I know a bit about it. In generally, as to how it used to work. So you could plan. You were planning 5, 10, 15 years for power station type environments, and that seems to have changed. In that long-term planning is gone. People are looking at the assets that are out there, and how they can basically contribute to, like, if you think fundamentally what's happened here is a whole pile of renewable being added to the grid. Some in Ireland, a good bit of wind. There's a lot of renewable and an awful lot of solar after getting added to the UK grid, and it has caused all sorts of problems. Now people are trying to figure out very quickly, how do you balance? And they're looking at, is the short term, is there enough in the short term to do that? Say, there's a figure bandied around the UK that 50% of the balancing can come from the short term or from the industrial and commercial load. The other 50 is going to have to come from somewhere else. But beyond that, then a lot of it has become more reactionary, I think, than it used to be. It's not a big planned system like it used to be. And I don't see it going back to be that anymore, because you've even got an unstable renewable coming in. And we want that because we don't want to be burning the planet, I suppose. So because we're doing that, the whole nature of the business has changed. But it's definitely short-term at the moment.
No, I just a light-hearted point. I've been going to energy storage conferences for about the last 5 years in many different countries. And 2 years ago, you didn't see people from banks at energy storage conferences. And from when you spoke to the organisers, they were like, no, the banks are not ready for energy storage yet. And there was a few venture capitalists or green funds. But this year I was at Dusseldorf, and it's a huge conference. And there was a whole afternoon session only for financing, funding, banking. And there was, I don't know, there must have been 15 different banks there. So this is a good benchmark of the enthusiasm for whether it's an investment risk or not. But also, if you look at our grids, there's about a 30% overcapacity in Europe now for power generation. But as we start to retire our thermal assets, which there's no doubt this is going to happen, Germany's already started, the UK is looking a bit wobbly, then we're going to have more and more variable generation. And it's almost impossible to build a transmission line anywhere in the world these days without huge delays in the planning process. So there is absolutely no doubt in my mind that all the action is going to be at the demand side. And if this is the case, then it'll be about distribution, storage, flexibility. And I think investments in any part of this part of the system are very wise indeed.
Sorry, just to really quickly follow on from that. The big thing, everything which we've heard about here has lead times, 6 months, 12 months, so very, very short lead times compared to transmission lines or power stations where you're looking at 10 years. That means there's huge certainty there that these things which can happen quickly will happen, and you won't have long projects which end up as stranded projects.
Thanks. I think we've just got one last question at the back.
My name is David O'Neill. I have a company called Acts Ireland, and I'm a representative for the Institute of the Motor Industry, which is based in the UK. Recently, they showed figures of an increase over the next 2 years of 53% in the sales of electric vehicles. Now, we can already see that starting to happen. You've Elon Musk just launching the Model 3. And again, areas like range anxiety, 215 miles, which is 350 kilometers before a full charge. They have taken massive orders for these vehicles, and people are becoming more familiar. More of the brands have got involved in this technology. And the reality of it is that it's now starting to take, a lot of energy. It's taking off. And that in turn is going to put, another tension on the grid that's there. Now, there is capacity, and purely that capacity, and I would imagine the capacity will be taken up on night rate, where people will be charging those cars. And it's not just made up of electric cars alone. There's a complete, variety of different types of technologies mixed in there. You've got, hybrid cars. But what is happening is people are becoming more trusting of this battery technology and becoming more familiar with it. So whereas, you may discuss it as a commercial entity or as a commercial sense, and that's fine because you're familiar with this area and you've looked at it, you've researched it. The domestic guy is now going to be looking at this and going, hang on a second, how if we were to put some sort of a battery support unit in our home, rather like we have in our car, and if we could reduce the amount of electricity that we're using, not taking away from the grid, but using it more efficiently. And it's sort of getting back to some of the systems and that we were talking about earlier on, but at a domestic level. Surely that's going to change the way we use electricity, our demand for electricity. So our whole view of peak times and all of that has to change. And has there been any long-term view on that? Our industry, the motor industry, has been turned upside down in the last few years. Agendas have changed. We're looking at electric vehicle and all that area. We're looking at autonomous vehicles, self-drive cars, and we're also now looking at connected cars. And we've had to deal with a lot of that change. And I know there's a lot of change happening in the use of energy, but there's a lot of comparisons here. And there's a lot of things here that we've got to look at what's coming down the pipe. And, to use an expression that Carlos Gohan used, who's the CEO of Renault Nissan, a lot depends. there's lots of change going on around the world in terms of production and manufacturing. But our necessity to use powers wisely, and we know that, we're becoming more and more aware of it as individuals. Has anybody really looked at what they feel is going to be the long-term usage or solution for this? Has anybody got a view on this on the panel?
We've invited a kind of a specialist from our e-car teams, maybe just to give an update on V2G and where we see that progressing to. So maybe, yeah.
Hi, my name's Joe Mooney. I'm with ESP Cars, and just to give you a bit of a talk on that, which is often referred to as V2G, which comes under VTX, which is also a broader scheme of things. Like, so we have vehicle to home, vehicle to building, vehicle to grid. These are all three different areas of where they see the use of the energy that's stored in cars and how it can be best used or will be used, or what business potentials they are with this new emerging of electric vehicles on the market. So like what we're going to probably see to begin with is probably more so, and what we've already seen it in the likes of Japan, is vehicle to home, where you have emergency situations and essentially your car can be used as an emergency backup energy supply, like particularly towards lighting and things and communications. You also have a lot of work going on in terms of vehicle to building and vehicle to grid. Now that's a little bit further away, but there is some work and pilot projects being done in those areas. It's I would say it's at least 5 years before you're going to see something like vehicle to grid to really come alive. And the focus isn't really in delivering energy to the grid. The focus is more like to manage the energy balance of load and generation on the grid. So like when you have over demand, that you can turn over control of that to the grid, where they can reduce the load that's being drawn by electric vehicles on the grid at a particular time, and thus rather than bringing in more generation at the same time. So that's the sort of thing like with vehicle to grid that's being looked at. Somewhat you can bring energy from vehicles onto the grid, but like, you know, that's to a lesser extent. And like, of course, you know, business models have to be developed, which the customer and the drivers of these vehicles would want to enter into agreeing to such things being done with their vehicles. So like, there's a lot that needs to be done in terms of that, and also in terms of policy around the grid itself and how the grid is going to be managed. So like, a lot would have to change, and I think there's a lot of like barriers, both not so much technical, because we know it can be done, but more so politically and regulatory. So I think that's what's going to keep it down the road for a little bit. But like, you know, it's been looked at all over the world how this can be done. Like, and we are going to see dramatic changes, but it'll come bit by bit. So I don't know if that answers your question.
Really quick.
Yeah. Just to follow on a bit from that, like we maybe started the session talking about decarbonisation. We tend to think quite a lot about decarbonisation of electricity in ESB. We definitely do. We heard from Tesco looking at heat and biomass, which is decarbonising the heat sector. Transport is about a quarter of the emissions in Ireland, and the electric car is a wonderful tool to work at decarbonising at least the personal car area of that, and potentially the fleet delivery vans with some models coming on in that area as well. And the range seems ideal for Ireland. It allows you to get from one county to almost any other county within that sort of range. It's very suited. Electric Vehicles has put in a fast charging network, has put in a national network, which is extremely sophisticated. So there's a huge opportunity in there, and electric vehicles are one of the solutions towards decarbonisation. Really one of the key things there is how efficient electricity is. Turning electricity in a car into forward motion is around 92%, 92% efficient in the electric vehicles on the market at the moment. A internal combustion engine is somewhere like 10-12% efficiency petrol to forward motion. And that's why electric vehicles are so valuable in that future decarbonisation. I won't go on about that. Joe knows more, and you can speak to him afterwards.
Okay. We have no choice anyway.
Yeah,
we have no.
Just for COP21, which we've all signed up to, by 2050 we need to fully decarbonise power generation and fully decarbonise transport, all of it, in Europe. We have no choice.
We have no choice. It's a question of speed and how quickly can we manage the transition. It's been a great discussion. And we've gone way over time, so I'd like to draw it to a halt. We're going to have a cup of tea and coffee next door where we had lunch. So I'm sure all of the speakers will be there. So if you have specific questions, please feel free to continue the conversation. I hope you've enjoyed it. You know, when we started the talk, we said we subtitled this "Use It or Lose It," and you know we think energy storage has great opportunity right here, right now. It's not an abstract idea that can drive benefit to businesses in the future. You know, it is a fast-changing industry. We do see new technologies coming on today, tomorrow, next week, next year. But right now, there are great opportunities for nimble companies who can move quickly. So I hope you've enjoyed the talk. I think each of the speakers brought something very different to the conversation, very different perspectives. You know, if you'd like to continue the conversation, we'd love to have a cup of coffee with you next door. Or we have a stand, a Smart Energy Services stand downstairs for the rest of the day and tomorrow. So please come and talk to us. And maybe we could just show our appreciation for the panel of speakers.